functions. Hopefully it's kind of a review from algebra. Some of you, it may have been a while. It's been a while. And so hopefully it didn't go too badly. Like I said, a lot of this should be review material. So if I want to calculate exponents, so we know that whenever you have something in an exponential place, then that's our power. So on your calculator, I always call it the up yours key. So on the calculator, you use if I can get my little pointer here, you use this little caret. I don't know why they call it a caret. I think up yours sounds better. And so in other words, 2 up yours and 1.4 and so on. So just how you would do these with an actual calculator. And you should be sure you're comfortable with entering these in your calculator. The only thing I would mention is, as you're going to see later, is if you have more than one thing in the exponent, you should put it in parentheses. All right, some laws of exponents here. When you multiply with the same base, okay, so the base is the big number, you add the exponents. When you have an exponent outside of your parentheses, when you bring it in, you multiply, so that's a little different. And then here you actually would put the powers on both of the values inside the parentheses. 1 to any power is 1. Anything to the 0 power is 1. This one gets forgotten a lot and is used a lot, you'll see in your future classes. The negative exponent, I can rewrite a negative exponent as 1 over and then make the exponent positive. Okay, and then this last piece here is just because 1 to anything is still 1, so that stays the same, bringing the exponent outside. But this step's the important one, that you realize that you can take something with a negative power, because what that means is it's going to be a very small fractional number and you can write it as a fraction. So let's go through a few examples here just to make sure you have these laws down. So for example, if I had 3 squared times 3 to the 4th power, well, we know 3 squared means 3 times 3. And we know that 3 to the 4th power means 3 times 3 times 3, right? And so 3 times 3 is 9. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And if you multiply that, you'd get 729. So no big deal, right? Well, again, if you use the nice little shortcut, you could say, well, 3 squared times 3 to the 4th power is the same thing as, remember, we add the exponents. So 3 to the 6th power. And if you look up here, 1, 2, 3, 4, 5, 6, you can kind of see that it works, right? And you get your answer. All right, let's say, what if I have 3 squared to the 3rd power? Then what this means is 3 squared times 3 squared times 3 squared. There's 3 of them, right? Because of that 3. Or in other words, 9 times 9 times 9, which again, 729. Or if you want to do this faster, then you remember your rules and you say that is brought inside by multiplication. So we get 3 to the 6th power and we get 729. So these rules actually are just to make things a little faster. Let's say if I, over here on the side, just once again, the reminder, if I write 1/3, that's the same thing as 3 to the -1, because remember, it's just understood that there's a first power, right? I always said if you want a nerdy kid and you say, how old are you? And the kid says 3, not my kid's gonna say 3 to the 1st power, right? Hey. And so, of course, working these backwards, if I had something, if I can get my pencil, like 5 to the -2, that would be the same thing. Bring the 5 to the bottom. Your exponent becomes positive, and of course you get that value. Okay, so once again, hopefully some little reminders there. If we have an exponential function now, notice the difference. This isn't like x squared. My variable is in the exponent. So in other words, a is just some positive real number greater than 0, doesn't equal 1 because that'd be silly. We said 1 to anything is 1. And so I'd have something like 3 to the x. And these exponential functions, actually, those of you that are going to BioCal, you'll see we use these a lot. So let's kind of look and see what the graphs of these look like. So if I want to graph this exponential function, 2 to the x, then I go back old school where I do a x column, I do a y column, I just pick values for x, and then I plug into my function and I get this graph. The reason that these are so important in biology, I mean they're important in every field, but definitely biology, is think of a population increasing exponentially. Think of, if there's a epidemic that's happening, I always say take one kid to daycare that's sick and see what happens. They all get sick, right? Here's even in business, number of cell phone subscribers at the end of the year, in other words, has risen exponentially. So the properties of the exponential function, okay, so once again, where a is just some number greater than 1, the domain, x good, x values, this is going to the left and to the right forever, so all real numbers. The range, though, notice it never hits 0, and it never goes negative. So this is it says right here, my horizontal asymptote. So what this is saying is basically if you raise anything to a power, you are never going to get 0 or a negative number. All right, and then it is increasing, constantly increasing, definitely 1 to 1. I can do my horizontal line test. And then you can see particular points that are nice that the graph contains to be able to graph right away. Once again, it's smooth and continuous, which this is nice to know when you get into calculus, why we like this function. Well, if I have something like this now, notice that my a is a value between 0 and 1, okay, or a fraction. If I go through and I look at this and I graph this, what happens here is actually it's going down, okay, and once again, if you think about it, as I'm plugging in these values, notice what's happening is my fraction here getting smaller and smaller and smaller, and so this would be a decreasing function. So basically just showing here, if I have my 2 to the x, and notice the difference here on this last function, I turn this into a negative exponent. Remember, that's important. And typically in biology, like on the left-hand side, certainly we can see that this is increasing my exponential function. But on the right-hand side, we typically call this exponential decay because it's definitely decreasing. And so the properties of this function, notice that where it's still an exponential function, but where my base, my big number, is between 0 and 1. So what does that mean? Fractions. Okay, so that would be fraction values. Once again, my domain's still the same, all real numbers, and my range, once again, still positive. There are no x-intercepts. I still have my x-axis as my horizontal asymptote, and then it's decreasing, and then some nice little points that are nice to be able to graph it very quickly. All right, so once again, hopefully it's like, yeah, I kind of remember doing exponential functions when I was paying attention in my algebra class. So if this is new to you, the properties are the big part to be able to get those properties down when doing calculations. And we will continue in the next video.